Hi everyone, so in today's lesson we're going to have a look at how we can use Python to create a Christmas snowflake, and then in the second part I'm going to show you how to actually have these snowflakes falling from the sky and create a very Christmassy snow scene. So in order to do this you're going to need the official version of Python, which you can download from the website. So it's here at python.org/downloads. Now, I know that some of you probably use REPL.it or maybe some other Python interfaces, but I think that in general those are going to be a little bit slow for this. It's going to work best if you have the full version of Python installed on your computer. Okay, so once you've installed Python, you can start up idle just like we would in school. And then once you've started idle and you get a window like this, I'm going to go to File, and New File, and create a new file to type my program into. So inside the new program, the first thing you're going to need to do is import turtle and import random, because those are the two packages we're going to use. I've actually got a file which I started earlier on, which has that typed in. So from turtle import star, from random import star, those are going to give us the commands that we need in Python to do the work today. Okay, now you might have used the turtle graphics system when you were in Key Stage 3, maybe in Year 9, and what it allows you to do is that the turtle is a little arrow which appears on the screen in Python, and we can move it around by giving commands like forward. So forward 100 would move the turtle 100 pixels forward, and on the screen it looks like that. So you've got this little arrow and then it goes forward 100 pixels and draws a line. And you can go backward as well. So if I go forward 100 and then backward 100, it will draw the line and then move the turtle back to the starting point. Now, as well as forward and backward, you can rotate the turtle. The word right moves the turtle clockwise, and the word left moves it anti-clockwise. So if I write right 60 and then run the program, then you can see that the arrow has turned 60 degrees. And that can be useful because I can put it inside a loop. So for example, if I wanted to repeat this 6 times, I can use a for loop like this for count in range 6, and then select those commands and press the tab key so that they go underneath this for loop, and they're indented slightly, and that means they're going to be repeated 6 times. So when I run the program now, it draws 6 lines going out from the center of the circle. Okay, now that is actually going to be pretty useful for our snowflakes. So let's use this shape with 6 lines going out from the center of a circle to build the snowflake. And the first thing I'm going to do is give this shape a name. So I can do that using the def command. I write def snowflake, then do an open and close bracket and a colon. Now this means that I'm giving a name to the shape, and I have to select all of the commands that I use to make the shape and press the tab key to move it in a little bit. Now what this program does now is it says what a snowflake is. It doesn't actually draw any snowflakes, so if I run the program I won't get anything on the screen. But what I can do now is write the word snowflake whenever I want a snowflake, and it's going to draw that snowflake on the screen. Now this is where we can start to use some more advanced techniques, because let's say I want the snowflake to be different sizes. What I can do is inside those brackets I write the word size, and then that word size I'm going to put instead of the word 100. So remember, before I drew a snowflake where each line was 100 pixels long, but instead I'm going to replace 100 with the word size. And now I can type a different size in the bracket. So for example, let's put 200, and that 200 will go into this variable called size, and that means that I'll go forward 200 and backward 200 which is going to create a snowflake which is twice as big as the previous one. Okay, so this is kind of useful, but what's even cooler is that if we think about a snowflake is an example of something called a fractal. A fractal is a type of graphic, a type of image, where each part of the image is actually a copy of the image made smaller. And we're going to use the nature of fractals to draw this in Python. So what I do is, after I've moved forward to the end of the line, I'm going to make a smaller snowflake. So what I'll do is I'll take the size and divide it by 3, and I'll draw another snowflake at the end of that line. Now if I ran this program now, it would go forever because it would keep drawing smaller and smaller snowflakes. So I do need to have a limit where it's going to cut off, and I'll do that using an if command. So I'll say that I should only draw a smaller snowflake if the size of the current snowflake is bigger than 20. So if the size gets smaller than 20, I won't draw any more snowflakes. If I run that now, we can see that it starts drawing a snowflake made up of lots of smaller snowflakes, and it is going to draw a whole snowflake eventually, but it's going to take a little while. You can see it's kind of slow. So here's a way you can speed it up. What you do is, before you ask to draw a snowflake, you write tracer 0, 0. And this says, I'm going to draw some stuff, I want it to go really fast, so don't draw anything until I've given you all the commands. And then once you want to update the screen, you write update. Now if I run the same program, it appears with everything at the same time. So you can see that this creates kind of an interesting snowflake. Now you can play around with some of the parameters. So for example, if I don't divide size by 3, but I divide by 2, that creates something like this. So it's basically a triangular grid. If I divide by 4, then I get another type of snowflake. It's a little bit more sparse at the edges, maybe. I think actually it might come out the same. No, it is more sparse at the edges. Okay, so there are a couple of other things we can do to make our snowflake look better. So the first one is, let's change the background color. To do that, you can type S screen.bg color, and then you can either provide a word like black, or you can provide a hexadecimal color. I think that it looks best if I actually provide a dark blue, so I'm going to write a hexadecimal color for dark blue. Dark blue just looks a little bit softer than black. Black can be a bit harsh. And I'm going to set the foreground color to white. Now notice that in both cases you have to spell color the American way. And if I run that now, we've got a different color palette, and I think it looks a little bit more Christmassy. Now another thing that we can do to make it look a bit better is to make the lines thicker. So to do that, we write width, and I think I'm going to use 4 pixels for the lines. Let's test that out. Okay. And another thing that I'd like to change is that this turtle in the middle, you can actually still see the arrows. So let's hide that. I'm going to write at the top, hide turtle, and run that program. Okay, so guys, this gives us a quite a neat little fractal snowflake, and I can change the size. So for example, if I wanted a snowflake, if I wanted the snowflake to be half the size, instead of 200, I can put 100 or 50. So I can change the size of the snowflakes, and I can draw snowflakes anywhere I want. And in the second part of the video, I'm going to show you how you can use that to have snowflakes falling from the sky in a simulation of falling snow.